Hi. Thanks for having me. So I don't know if we explained the whole thing about tonight, but it was like the first speaker is looking forward, new person speaking, and then I'm the looking backwards person. So I don't know if I should be facing behind me, but that's the whole premise. I've spoken before at SydJS, and unfortunately, I'm speaking again tonight. So time's going quickly though. So before we get into it, I'm currently a full-time dad on 1 year of parental leave, and I'm looking after these two. So I've got a 3-year-old daughter and a 4-month-old son. And my son is pretty sweet, not gonna lie. And as everyone knows, thank you so much. Thank you so much. How great are young parents? I'm not that young anyway. So as we all know, when you become a parent, you have to pick a new skill off the skill tree. So for me, I picked barbecuing. And I've been doing a lot of barbecuing. It's great. It's a good thing this isn't like, I don't know, Sid Barbecue, because I'd tell you all about how great coal barbecuing is and how super tasty. So if you take one thing away from my talk tonight, go pick up a coal barbecue. You won't regret it. Cool. So today we're going to be talking about dynamic creatures and concurrent features. And what is that? It's a rhyme that I made backwards because I'm going to talk about concurrent features, but I need something that rhymes with features. So creatures, there we go. Managed rendering of JSX elements and a gotcha of React concurrent features. It's kind of like a sub note at the end of the talk. Hopefully it's interesting. Cool. So for 2 years, I've been working on a side project called Triplex. I'm insane. I'm literally a psychopath for working on it for so long, but it's a pretty neat visual development environment for React. And it started out as a React 3 Fiber editor. So maybe 2 years ago, I was building a game, and it was a little chicken point and click game. And it was super difficult to do anything. I'd be like moving things around. Sorry, I couldn't move things around, right? I would be in code just saying, okay, the position should be here. Is it correct? No. And then just do that for infinity. Made an editor that can save back to source code. So you can like move things with visual controls, save it, goes back to source code. It's pretty neat and super productive. But realized pretty quickly, at least in the last 6 months when I was working on the VS Code extension, because it's also a standalone app as well, not having React DOM support, so not being able to render divs and a canvas element and buttons and stuff, was actually super annoying, especially for people in the WebXR community, because they would want to render their buttons to say, enter VR, but they couldn't because it would blow up. And yeah, not fun for anyone. So this whole talk is kind of centered around how can I have a visual editor? How can I have this product be able to scale between both React 3 Fiber and React DOM? Cool. So if you boil Triplex down, it's basically just a managed JSX environment. And what that means is you give it a component that returns stuff. Oh, sorry, this is also a React talk if you didn't realize. Sorry about that. I would talk at React Sydney, but it doesn't seem to exist anymore. Anyway, so you give it a component, a React component, and it will manage everything around it. So the environment, what it needs to run that component, all the like visual controls and everything, Triplex handles for you, including dependency management. And you give it a component and it will give you back a box because this component returns a box. And you can try and give it a div with a button, and it'll give you back, of course, an explosion. It doesn't work. You've tried to use it. This tool is the worst, and I'm never coming back again. Where did you learn to code? So not productive for anyone. But this is what we want. We want it to render a button, at least for the simple case. And we also want it to harmoniously work with both. So it's not just render React DOM or render React 3 Fiber. It's have both work together and kind of look like a cohesive thing rather than this like haphazardly put together visual renderer that I've been working on for 2 years. So component usage scenarios. So what I'm talking about is how we use components and what we're going to return from them. So for a regular flow, we've got kind of three things that we would generally return from a component. We have host elements, so div from React DOM, mesh from React 3 Fiber. We've got locally defined components. So inside the same module, you could grab a component, use it, return it, and that should work. And then we also have components from other modules. So this could be inside your own project, or this could also be from node modules. And all these scenarios need to work in regards to being able to know how I should render your component. Is it React DOM? Is it React 3 Fiber? What do we need to do to make it work? Cool. So like anything in life and like kind of any job, you'll want to jump ahead and say, I'm going to do this implementation, but taking a breath and thinking about what are the constraints I need to make this architecture work really well is something that I kind of sat down and had to think through just a little bit. So the two main constraints, like anything, especially in the JavaScript community, it has to be fast. So that's why Triplex is not written in Rust. I'm sorry. I didn't want to learn another language. But it has to be fast for compile time, for initial scene load, and for hot module reloads. So hot module reloads being I've got my app running, I make a change, I save, it's very quick to reload, as instant as possible. And it also has to be resilient. So this is kind of like a non-negotiable constraint. Triplex can't crash or need to be restarted. Ideally, it's all graceful. So I might be creating a React 3 Fiber component, but maybe I want to bring in a canvas component. Maybe I want to bring in a button, and it should gracefully kind of migrate from one environment to another without having to restart, without having to get an error, and so on. So when we look at a module graph, so pretend this is like a folder structure. We've got a bunch of files, and we're just defining which module is importing which module. When we talk about performance tuning and how we can scale something effectively, we're really talking about cache invalidation and minimizing it to the smallest amount possible. So for example, when I modify, hypothetically, this sidebar component in the sidebar file, if it made everything recompile and get flushed to the front end, the ceiling for how fast this can be has been lowered dramatically. And what we want is it to only change the single file, the single module, because at that point, we can make that very fast and then nothing else has to change. And if you look around the JavaScript ecosystem, all the big dogs are just using this playbook. Like every performance tuning is all about, can I parallelize across multiple workers? And can I make sure that for any change that has to happen, can it be the smallest amount of change possible? That's why you'll see things like incremental builds where you've built it once and the next one's fast. It's because it's all cached. And then also when you're running the app and you change something, again, it's very quick. Why? Because, well, we don't have to invalidate much. So having an architecture that can scale to this kind of performance needs was incredibly important. So when we go back to defining constraints and we try and think about, okay, well, what do we have to do to be successful? Well, again, looking at our playbook, there's three main things. So we've got metadata that we're going to create in Triplex or in the backend that has to be scoped to a single file. So we can't escape this module, go to another module to get information. We only can use the data that's inside this module. And that's, again, to keep the cache and validation as small as possible. And then we're going to deconstruct the analysis. So every component can have some metadata associated with it, in your project at least. And then we're going to piece it back together at runtime. So again, if we remember the constraint of this metadata, this code transform can only be scoped to a single module. We can't look at this as a compiler and say, oh, it's 3, so I'll just inline it. But if we run this at runtime, well, we can evaluate it to 3. So that is the whole process of we'll deconstruct it. Each component will have a little bit of metadata associated with it. And then at runtime, we can piece it back together and get the actual story of what the environment needs to be. So we've kind of got our constraints. We've got a little bit of the theory in our playbook of, the big dogs doing their performance. So let's kind of dig in a little bit to what does component analysis look like and how can we actually use it? Cool. So I'm using Babel in this project. It's not any of the cool Rust players like SWC and Oxide compiler, but I don't know how to code in Rust and I don't want to do it. And I just want to code some JavaScript and get it done. So I use Babel and it's fast enough. Again, we're just doing incremental compilations, so it doesn't really matter. And the benefit of Triplex as well is it'll only open the component module that you've opened and its dependencies. So we're not doing full project compilation at one time. We're just doing a very narrow view of the bigger pie, which kind of keeps things fast as well. So component analysis, we want to figure out what the environment's going to be. Should this be a React 3 Fiber environment? Should this be a React DOM environment? We've got some signals, not those signals, that we can use to figure this out. We've got JSX, so we can look into it and know, well, given some amount of JSX, it's going to be one or the other. And then we've got hooks. And thanks to the rule of hooks, hopefully everyone, or at least a subset of you, know what rules of hooks are. One guy, sweet. Two, sweet. The too long didn't read for rules of hook is that there's like some rules, right, that you need to follow for hooks to work. And the main thing is they need to be at the top level scope of a component. So basically we know if they exist, then this component must require a certain environment reconciler. A reconciler being React DOM, React 3 Fiber, React Native, just the different flavors of React. Anyway, so this is another signal we use. I'm going to give you 3 examples of how this analysis works, and hopefully it's interesting. If it's not, I'm not sorry. So we have a simple component. It is a component that returns a box, but it has a fragment. So when we do this analysis, we're doing a thing called AST traversal, abstract syntax tree traversal, but I'm not really going to represent the AST here, but just think about if we're going through a JavaScript file, it can be represented as a data structure, and that is a AST data structure. So when we begin our analysis, our traversal, what we're really doing is we're going through each element and then just kind of figuring, do we want to do something? So the first element we hit is a JSX fragment shorthand, and this gives us no signals. This can be used in every reconciler, it can be used everywhere, so we just skip it, we keep going. But then we find a mesh, and in our encyclopedia of what reconciler has what host element, we know that this is a React 3 Fiber host element. So that's our first found host element. We then keep going. We've found a box geometry, but we've already found a host element. So we just skip over it and we keep going. We've found no hooks. We've found no custom components, but we've found a host element. And so based on this analysis, we can say this component is definitely a React 3 Fiber component. We tack on some metadata, and then now we can use that when rendering this component and say, well, okay, we'll render it accordingly. Number 2. So this is slightly more involved, but the same premise, right? We go into the component function body, we've found a hook. Similar to the fragment, this can be used everywhere, so it gives us no signals. We keep going. We've found a React 3 Fiber hook. So our first found hook source becomes React 3 Fiber. We keep going just for good measure. We've found a mesh. We know mesh is React 3 Fiber, so we've found our first host element source. And then we keep going. We've already got it, so we skip this one. And then that's the analysis. No custom components. This module or this component is a React 3 Fiber one. Last one. I promise. So for this one, again, slightly more involved. Found a hook. Yes, the same thing. Have to skip over it. We've found a custom component. We grab the name and we're going to use it later. We keep going. We've found another custom component, but we don't need to hold on to it because we've already found something else. So we keep going. We've found a div. That's a host element. So now we put the host element source as React DOM. And then that's it. We've got no more traversal to do. We've exited this component. And then now we've got a host element. We don't have a hook. And we've got a custom component. But now when we're putting the metadata here, again, we're scoped to just this module. And we can't escape this module to know what card is. But following the point about deconstructing the analysis, every component has a little bit of metadata associated with it. We don't need to know at build time what it is. So we just put a reference to that component's metadata. And then at runtime, we can just evaluate that expression. So I just literally call component xxx.root, and it'll resolve to React DOM. So then that allows us to, again, have a very granular analysis, each component, but we don't need to escape module boundaries. We keep that cation validation as minimal as possible, but we still get the end result, which is we know what this component needs to be able to render it. And it works. So this is a React 3 Fiber component. This is the original chicken. It's been here for the whole journey, and hopefully it'll stay around. And this is also the React DOM example as well. And because it's using all the same backend, we can visually edit it, we can use the controls, we can save it, it goes back to source code, and it all just works. Oop. But it's not all daisies and marshmallows. My daughter would love that because she likes baby chinos. There's edge cases, and I'm not going to get through all of them, but I'll give you a little sneak peek at some of them. So JSX composition. What you see is not what you get. So this component is actually a React 3 Fiber component. But if we were doing our naive traversal, saying we've found the first div, well, we could incorrectly say this is a React DOM component. But then if we did nothing, this would just blow up because it's not. It's a React 3 Fiber one. So handling those different kinds of composition patterns, very important. Component declaration. So components can return itself. This one obviously will return itself for infinity, but let's just pretend it's not. We need to exclude it. We can't include the same component in the analysis. So we kind of omit that. Very similar to how we did the emitting of JSX fragments. And also, it could just be not statically known. So we've got a component here that gets returned from a hook, which is great, but we can't use it in our analysis because it's not available in the module scope. And then the last one is switching between components. And you might be wondering, that has nothing to do with analysis. And you'd be correct. So after implementing this feature, a regression was introduced because, like every professional developer, we put a bug in there just so someone can find it. And the problem is now how we load the component has changed, or how we load the scene. And every time you switch a component, it will unmount the scene, wait for it to load, and then remount. Concurrent features. So I would say arguably React's defining feature was React 18, well, even from React 16, introducing suspense, declarative loading patterns, and then kind of evolving that as we go. Like, fantastic. Everyone's doing this now. And suspense is a cool component. If you're not familiar with what it is, all it is saying we want to declaratively declare where our loading states should be. So here, for example, I've said our loading indicator should go above page. So then when anything under page says, I'm going to request data. I'm going to throw suspense or trigger suspense. It will fall back to that suspense boundary, show a loading indicator, and then at some point in the future, come back with the new stuff and re-render. So for example, we've gone from a sidebar, we've got new data, and now we're showing a TOC component. And that's in essence what's happening here, right? We've triggered suspense. So we go back to the nearest suspense boundary. It comes back eventually. And then now we've got our stuff. Fantastic, we're done. But we're not. So that experience was kind of like the early days of these declarative loading patterns. And the React core team very quickly realized that like end developers need more control to be able to say, well, maybe I don't want to unmount or hide part of my tree while it's loading. I want to have a stable application and keep things just visible while I'm waiting. And that's what the transition APIs are for. So there's a hook called use transition. And there's also a top level function you can import called start transition. And in essence, when you trigger suspense, you can put it inside a transition and React will hold on to it. So given the same example we were looking at before, I trigger suspense, but it's in a transition. So React will hold on to that tree. And then when it's finally resolved, display the new stuff. So that we, at this point, we've never shown a loading indicator. We've just held onto that tree, kept a stable experience, and then rendered the new stuff. So they hold the JSX tree in place for transitions until data resolves, or if someone would like change state elsewhere. In a regular app, it could be navigating to another page. It's great for keeping your UI appearing stable for a better user experience. And again, going with a narrative of just giving end developers the tools that they need to do their jobs, you can show granular loading states if you need, using the result from use transition. So I put that state change in a transition, and it didn't work. Far out. Super annoying. Why didn't it work? Hopefully someone in the audience knows, but if you don't, that's sweet, because you're going to find out. There's a gotcha. And the gotcha is this hook. It's called use sync external store. If you go to the docs and you scroll down, there's this big caveats section. And this hook has the most caveats out of any hook on the React docs, and for good reason. This body of text, if I just summarize it, says transitions don't work with whatever's returned from this hook. And probably maybe some of you are thinking, well, I don't use this hook, so I'm sweet. You might not use it, but fucking everyone else does. And for anyone using intermediate state, like now you need to know what library you're using, how many abstractions away from use sync external store am I? And then you have a split brain of, am I using the result from this hook or am I using it from state? And you need to go through a couple mental gymnastics of knowing. And like, I've always thought this hook, it's like synchronizing, right? Use synchronize external store. But at this point, I just want to rename it to use synchronous external state or store, whatever it is, because that's what it is. It breaks concurrent features and nothing works. So it's absolutely useless. So we just reenact the bell curve meme, right? Like we all started out just using React state. And then we're like, we're geniuses. We're going to just use all these cool state management libraries. And now we're on the other end of the spectrum where we're like, okay, we'll just use React state and context. Yeah. So that's what I did. I killed Zustand, which just hit 50,000 stars. Mind-boggling. In a good way. Like, it's a good library. I swear. And I replaced it with state. Just regular old React state. That's it. And yeah. Sweet. Cool. Yeah, that's it. That's the gotcha. Hopefully you didn't know. Maybe you didn't know that before. If you did, I'm sorry. I'm not sorry. Cool. Thanks so much.
Michael, are there any questions?
I sort of don't understand some of the things you're talking about, but
Yeah.
what if you put that state, like you got the transition, you just put in a wrapper, and then you sort of pass the state up from the context of, or this, from Zustand, and you passed it up, passed it up to something which is a little bit more logical for the transition into the wrapper. So then, it's just sort of something that the transition's going to understand. Would that work?
If the state is returned from Zustand, which in turn is returned from usync external store, no.
Okay, but you couldn't. I mean, because then you could just remap it onto something more local to the component.
Oh, I mean, yeah, that'll probably work. Yeah,
okay,
but
it's not that pretty.
Yeah. As long as the state transition gets fired from something that React owns, it'll work.
Okay.
And specifically suspense being triggered. So, like, if I like the use case or the sequence of events, right, is I'm in React, I've got some state, I start a transition. In that transition, I'll set some state. And then anyone who's listening or like who's using the output of that state triggers suspense, then the transition will work. So to your point, if you had a Zustand store or anything that's returning usync external store,
you'd probably
and you had an effect that would like synchronize it or something, that would probably work. But well,
yeah, or a watch or something like that. But the thing is, if you pass through the state directly and you say this state is without having some sort of transcode, it's still going to be the Zustand state coming from the Redux. So then it would be broken in that case. Sorry.
But yeah, basically just you follow the breadcrumbs, and if it is sourced from React state, it'll work. Like in the super simple case, just if something triggers suspense from React state, it'll work. So yeah, if you had some like daisy chain state to try and sync Zustand state to React state, that'll totally work. But that's wild, man. Like, well, I mean, there's really only one transition in React, right? At least when we talk about suspense. Yeah, well, I mean, yeah, because Fiber has a lot of declarative loading patterns. Yeah, like it's very common to like load, like you'll mount a component and then it'll start loading a 3D model and stuff. Yeah.
Yeah. Okay. Cool. Thanks.
Yeah, I had a question. So my initial kind of thought was like, oh, could you just examine the imports and say like, if you import from React through Fiber, that's like enough. Is it correct to say that you only care about the root component, right? So it's like can you have React 3 inside React DOM and you only care about React DOM as the root, right? And then vice versa, you could have, I don't know if you can have DOM inside React 3.
I mean, there was that one example where I had the HTML component, which is from Dry, which I only know because I watch hockey and there's a guy called Dreisaitl. It's German. Anyway, I digress. So yeah, like you can have React 3 Fiber in React DOM by using the canvas component. So like I didn't really touch on all the fun edge cases that I had to go through, but like the premise is like some components assume an environment. So the canvas one assumes you're going to be rendering in React DOM. So if we find that, well, okay, well, we know that it has to be React DOM. So we'll render the environment as React DOM. And then vice versa, the like HTML inside 3 Fiber, like there's that HTML component where you could put HTML in, but we basically omit that. Like it's almost like a nothing burger, where we're more interested in the first thing, at least first custom component found. Yeah.
And so that's why, yeah, just examining imports wouldn't be sufficient because you don't know which is the root parent.
Yeah, well, it's one signal. It's one signal, which we do use for sure. Basically, if there's like anything that comes from like React 3 dry, and it's like at the top level of the component, then we assume it's going to be top level of the return. We assume it's going to be React 3 Fiber one. Vice versa, like the canvas we treat differently, and so on. But yeah, like it's all about like, okay, we've like the authors of these components have left some breadcrumbs, and it's up to kind of XXX to figure out, okay, given all these breadcrumbs, it's probably going to be this. Yeah.
Awesome. Thanks.
Anyone else?
Awesome, Dukes.
Alex,
I always learn so much.
I'm on paternity leave right now. Hey, like my wife hates me. Anyway.
Are there cases where the breadcrumbs are not sufficient and it may be like,
yep,
you have to XXX yells at you and you just add the meta to say like, yeah, this is actually React DOM?
Hypothetically, yes. The scenario of wait, I'm sorry. Okay, this one. Where the hook is, sorry, the component's being returned from the hook. That was an edge case that I fixed in the last week, where someone kind of invented their own dependency injection thing, but it was using React 3 Fiber. So the kind of the fallback of this whole architecture, can I say that, is we haven't figured anything out, but JSX was returned. So we assume it's React DOM, and that mostly works. But then there's like cases like this where it's supposed to be React 3 Fiber and we have no breadcrumbs to pull on, so we just don't know. And then in that instance, at least for this one, I resorted to a hack where it was like, oh, the component starts with object 3D, React 3 Fiber. And that mostly works because most people don't do that. So it's kind of, it's mostly a resilient solution, but then there's a little bit of hacks sprinkled in just to give it more flavor, you know.
Next question. I haven't used sync external store, but it feels bad that like you mentioned XState and these MobX and other things.
Bro, everyone is using it.
But it feels like a pretty bad situation if these super common state libraries just don't work with React transitions.
Yep.
Like, you know, this is totally outside of your talk, but do you happen to know if there's any plans or anything about like how they're going to solve this? Because it feels like something that they would probably want to solve. It's okay if you don't know.
Oh, I have no idea. No idea. But I mean, like I was talking to Ricky from the core team, and his take is just use React state and context and don't worry about tearing. So the whole point about, so there's one library on here from the Poimanderers collective that is not on this screenshot because they don't actually use sync external store. And that one, I can't actually remember the name. It's the Atom one. Anyone know? Anyway, the main premise is like right now you kind of choose between trade-offs. So using sync external store is great for like atomic updates. So given one, and this is the reason why it's synchronous, right? So given one state change, it will, with guarantees, update the entire tree, and you won't have tearing, meaning at like for 1 millisecond or something has the old state and then something has a new state, right? And that's why it's synchronous. That's why it bails out from transitions. But you don't have that same guarantee with React state, right? Because something can trigger suspense and then be waiting for data, show the old stuff. And you know, at least from migrating between 17 to 18 of React, like a lot of the state management libraries were like, well, it didn't do this before. I don't want to do it now, right? So that was what was kind of proposed as the almost migration path. I think in the future, the reality will just be embrace tears just for a little bit. React will self-recover, and you can guarantee that you don't have a split brain world of where does my state come from, and is this going to work with a transition? Because if you're working with like 100 developers, like if you're at Atlassian and you're working on Jira, and there's like 1,000 people or something, Actually, I don't know the numbers. Also, I work at Atlassian. You're in for a bad time because you just don't know. And it's not really productive for anyone. And I'm pretty sure Meta's not using any of these libraries, right? They're just kind of leaning on React state. So, and GraphQL.